Hi guys, I am recording this little conversation as a follow-up to the standards discussion that's on our assignment list this week. Basically, if you've read this, and I hope you have if you're listening to this, we have a lot of misunderstanding about math in our world today. And in social media, Common Core math standards particularly have really been taken to task in the past few years. These standards have been politicized for whatever the reason, but I often see these things appear in social media, and this is one particularly that a friend of mine on Facebook had posted and had tagged me in. And basically, his response was, Andrea, I don't understand. This student has the right answer. This is why students can't do math. This is why everybody's so confused. Math is so different from how we used to do math. This is a friend who's my age. So, we went to school in our elementary years about the same time frame. As educators, though, hopefully I would expect that you would first start looking right here to kind of see what the targets are for this. It looks like for this assignment, we have a couple of targets here that says I can use multiplication strategies to help me multiply. This tells me this is a student who's in a grade where they're learning to master multiplication. And we also have a target here that says I can use the structure of a word problem to help me solve it. And we don't see any word problems per se. So I am assuming that this exercise is meant to address that first target. When it comes down to it, this is hopefully helping us see that the purpose of these strategies that we ask students to learn outside of just memorization of math facts or outside of standard algorithms is really meant to emphasize conceptual learning. Now, I have people ask me all the time, what is the difference? Why does it matter? Why does it matter that this student showed the sum of 5 plus 5 plus 5 instead of the sum of 3 plus 3 plus 3 plus 3 plus 3? If our goal is to get them to know what is 5 times 3 or 3 times 5, why does it matter? Well, the long and short of that is that's not the goal. The goal is not to get them to memorize what is 5 times 3 or 3 times 5, and nor should it be. Our goal is to get the student to understand that when we multiply, we are really just performing repeated addition. If we can get the concept of what multiplication is into the student's brain, the fact recall is something that will come later. We've sort of embedded that idea. We've given them something to attach this fact to. We've given them a foundation for understanding multiplication. If you're still having a hard time kind of understanding why these are different, it probably would have been easier to see if this educator had put this into a word problem. What the teacher has asked this person to model is, for example, if Johnny went to the grocery store and he bought 5 candy bars that were $3 each, okay? We have, when the person goes to check out, they would ring up one candy bar and another candy bar and another candy bar and so forth. Whereas what the student has actually modeled would be more like if someone asked that same person to go to the store and purchase 3 notebooks that were $5 each. When they would go to the checkout line, you would have $5 plus $5 plus $5. Yes, both of those receipts at the store would sum to $15, but they would not look identical. Those purchases would not be the same. So we're trying to get students to understand what's actually happening when we're performing this multiplication. In this case, we're repeatedly adding 3 5 times. In this case, we're repeatedly adding 5 3 times. And while they sum to the same thing, they're not the same process. It's not the same actually of what's happening there. In all of my years of teaching math, from elementary grades to high school to college, one of the things I've noticed is that people who often tell me they really loved math in elementary school, not always, but many times, were just taught this procedural approach of fact memorization and memorizing steps to solve problems. And usually those students, somewhere in algebra, most of the time it's in algebra 2, maybe the end of algebra 1, they really start to hit a wall, because no matter how intelligent we are, no matter how hard we work, all of us have a limit to our short-term memory. And when we only attempt to memorize steps or memorize facts, we're really accessing, for the most part, our short-term memory. Now, if we have a concept that we understand, start linking those facts to, or we use them often enough, we will start to embed those into longer term memory. And that's great. But in order to access some of the careers and the jobs where mathematics is so important, we really have to know more than just recall. We have to be able to understand the process of what is going on when we are coming up with these math facts. And if we can't do that, we can't apply them. We can't use that knowledge to make decisions and move forth. If you were one of those students who you never understood all of those things that other people memorized, or you didn't know how you could keep up with all of that list of steps, then the conceptual learning that we're going to look at in this class is probably something that you're going to enjoy if you really embrace it, because it's going to help you make a connection to math that you probably haven't been able to make before. As you read in the next couple of chapters, definitely do not skimp on the reading, because it really addresses a lot of these methods that emphasize conceptual understanding of the processes we learn in mathematics, not just the recall of the fact. When you respond to this, you can respond to me or you can respond to another classmate, just kind of responding to say, has this conversation changed your mind of what's going on here? Do you understand the difference in what we're talking about with a conceptual approach versus just a procedural and recall approach to mathematics? Maybe you can give some insight onto your own experience in mathematics. Was that you? Were you the person who liked it because it was procedural, or were you the person who hated it because it was procedural? This is definitely something I'm going to be reading, because as we continue throughout this term, a lot of our discussions will be based off of topics that you identify you want to learn more about in math, or topics that we can discuss to help clarify what a true conceptual and developmental and learning approach to mathematics actually is. So feel free to post your response. As long as I see your original and the response by Monday at the deadline, you should be good to go. Let me know if you have any questions through email.